Hi everyone, in this lesson we're going to look at how we divide numbers that are in standard form. So let's jump into our first example. It says calculate the following, leave your answer in standard form. We've got 6 multiplied by 10 to the power of 4 divided by 3 multiplied by 10 to the power of 2. Now before we jump into how I'll do this normally, I just want to show you how I might rewrite it so that I can see clearly what I need to do. I'm going to rewrite this calculation as a fraction. On my numerator I'll have 6 multiplied by 10 to the power of 4. And on my denominator, I'll have 3 multiplied by 10 to the power of 2. Now what I can do is I can split this into two fractions. On the first fraction, I've got 6 divided by 3. And I'm going to be multiplying that by 10 to the power of 4 over 10 to the power of 2. Okay. 6 over 3 is 6 divided by 3, that is 2. And 10 to the power of 4 divided by 10 to the power of 2. Remember, when we have the same power, we subtract our indices. We'll do 4 take away 2. That gives us 10 to the power of 2. That answer is in standard form, so that is indeed my answer. Now, one way is to write it out like this every time. The other way is to split it like this. I know I need to do 6 divided by 3. And here's the bit where people get confused because they might be tempted to put down a division, which is why I showed you this way. But I'm then going to multiply that by 10 to the power of 4 divided by 10 to the power of 2. I just need to be careful when I'm saying I'm multiplying and when I'm saying I'm dividing. 6 divided by 3 is 2. 10 to the power of 4 divided by 10 to the power of 2 is 10 to the power of 2. So of course both these calculations are equivalent. It's just different ways of showing you them. And if we do it this way, we just need to be careful that we do not write a division sign here. It needs to be multiplication. Pause video, give this question a go, try it either way, and then we'll run through your solution. So I've got 8 multiplied by 10 to the power of 7 divided by 4 multiplied by 10 to the power of 3. I like rewriting it as a fraction. I'm going to write it as 8 multiplied by 10 to the power of 7 over 4 multiplied by 10 to the power of 3. And then I'll think about it as two calculations, 8 over 4, and I'm multiplying that by 10 to the power of 7 over 10 to the power of 3. 8 over 4 is 2. 10 to the power of 7 divided by 10 to the power of 3 is 10 to the power of 4. I just subtracted my indices there. Always check if it's in standard form because it has asked for that. That number is in standard form. Okay, let's give our next example a go. 2 multiplied by 10 to the power of 8 divided by 4 multiplied by 10 to the power of 3. Let's start by writing it as a fraction as we did on the previous one. So 2 multiplied by 10 to the 8 over 4 multiplied by 10 to the power of 3. Then split it into two fractions. So 2 over 4 multiplied by 10 to the power of 8 over 10 to the power of 3. 2 over 4, I'm going to simplify to 1/2. Now that number is going to be less than 1, that's okay. I'll leave it as that for now. 10 to the power of 8 divided by 10 to the power of 3 is 10 to the power of 5. At this point, I'm going to turn my half into a decimal, so it's 0.5 multiplied by 10 to the power of 5. The question has asked me to leave my answer in standard form. I'm going to turn 0.5 into standard form. We've done several lessons on this before this one, so if you're not sure how to do that, check those out. But that is 5 multiplied by 10 to the negative 1 multiplied by 10 to the power of 5. So all I've done there, turn my 0.5 into this. Then I'm going to collect together my powers of 10, 10 to the negative 1 multiplied by 10 to the power of 5, add your indices together, and that gives you 10 to the power of 4. And that's my final answer. Pause the video, give this one a go, and then we'll look at the solution. So let's start by writing this calculation as a fraction. So 1 multiplied by 10 to the power of 9 over 5 multiplied by 10 to the power of 4. Split that into two fractions. That's 1/5 multiplied by 10 to the 9 over 10 to the 4. Then we'll look at what each fraction simplifies to. 1/5 is 0.2 as a decimal. And 10 to the 9 divided by 10 to the 4 is 10 to the power of 5. 0.2 is 2 multiplied by 10 to the negative 1. And then we'll just rewrite that. And then collect your indices together by adding them. That gives you 2 multiplied by 10 to the power of 4. That's your final answer. Okay, in our next example, we have one of the numbers not being in standard form. Let's start it in the standard way by rewriting it as a fraction. 8 multiplied by 10 to the power of 5. And on my denominator, I've got 200. I'm going to write 200 in standard form as 2 multiplied by 10 to the power of 2. That's the extra step that makes this question a little bit different. Then split it into your two fractions, 8 over 2 multiplied by 10 to the 5 over 10 to the 2. 8 over 2 is 4. 10 to the 5 divided by 10 to the 2 is 10 to the power of 3. That's my answer. Pause the video, give this one a go, and then we'll look at it in a second. So let's go ahead and write this as a fraction. So 9 multiplied by 10 to the power of 60. So an absolutely massive number. And then we're dividing that by 3000, which is 3 multiplied by 10 to the power of 3. Split it into your two fractions. So 9 over 3 multiplied by 10 to the 60 over 10 to the power of 3. 9 over 3 is 3. And then subtract your indices because we're dividing powers with the same base. 60 take away 3 is 57. Check it's in standard form, and it is. Okay, our next example, we've got some negative indices. 5 multiplied by 10 to the power of negative 3 divided by 2 multiplied by 10 to the power of 5. So 5 multiplied by 10 to the negative 3 over 2 multiplied by 10 to the power of 5 is equal to 5 over 2 multiplied by 10 to the negative 3 over 10 to the power of 5. 5 divided by 2 is 2.5. And then I have to be a little bit careful here because I'm dealing with negatives. I'm doing 10 to the negative 3 divided by 10 to the 5. I subtract my indices, so negative 3 subtract 5, which gives me negative 8. My answer is 2.5 multiplied by 10 to the negative 8. Give this one a go and we'll look at it in a second. So we've got 7 multiplied by 10 to the negative 6 divided by 2 multiplied by 10 to the positive 3. We've not looked at the other way to lay it out in a while, so let's do that. I'll divide my coefficients, so 7 divided by 2. And then I need to multiply powers of 10 being divided together. So that needs to be a multiplication symbol. 10 to the negative 6 divided by 10 to the positive 3, like this. 7 divided by 2 is 3.5. And then I'm multiplying that by 10 to the negative 6 divided by 10 to the 3. Subtract your indices, so negative 6 take away 3, negative 9. So this is 10 to the power of negative 9. Okay, next example. 2 multiplied by 10 to the negative 6 divided by 6 multiplied by 10 to the negative 4. So let's go ahead and write those as fractions. So 2 multiplied by 10 to the negative 6 over 6 multiplied by 10 to the negative 4. Split it into your two fractions. So 2 over 6 multiplied by 10 to the negative 6 over 10 to the negative 4. 2 over 6 simplifies to 1/3. And you could go straight to the decimal if you're happy with that. And then I need to do 10 to the negative 6 divided by 10 to the negative 4. I'm subtracting my indices. Be careful here because we need to do negative 6 subtract negative 4. So just be careful with that. That is equal to negative 6 add positive 4. And negative 6 add 4 is negative 2. So my answer to this fraction is 10 to the power of negative 2. Let's go ahead and turn this third into a decimal. That's one of those ones we need to know off by heart. It's 0.3 recurring. And I'm multiplying that by 10 to the negative 2. Now, this is not quite in standard form because this is less than 1. I need to write 0.3 recurring in standard form. Just off to the side because it's a little bit trickier. I'll show you how to do that. So 0.3 recurring, we need to think what our coefficient is going to be. It's not going to be 3 because that doesn't account for the digits that follow after the 3 because 0.3 recurring means 0.33333. So my coefficient needs to be 3.3 recurring. I do need to account for that recurring 3. Multiplied by 0.1. I then go and I think, okay, well, 3.3 recurring is okay. That's my coefficient. I need to turn that into a power of 10. It's 10 to the power of negative 1. And these are equivalent. So 0.3 recurring is equal to 3.3 multiplied by 10 to the negative 1. Let's go back over here and we'll write in our 0.3 recurring, but now in standard form. So 3.3 recurring multiplied by 10 to the power of negative 1. Multiply that by 10 to the negative 2. Collect together these powers of 10. That gives me 3.3 recurring multiplied by 10 to the power of negative 3. That is in standard form, so that's my answer. Pause the video and give this one a go. Okay, let's start by writing this as a fraction as we've done most of the lesson. So 5 multiplied by 10 to the 10 divide that by 9, multiply it by 10 to the negative 8. Split it into your two fractions, so 5 over 9, and then we're multiplying that by 10 to the 10 over 10 to the negative 8. 5 ninths is one of those recurring decimals. We ought to know it's 0.5 recurring. And then subtract your indices, so 10 subtract not 8, but negative 8, like this, which is equivalent to 10 add 8, which is equal to 18. So this is 10 to the positive 18. Not in standard form because 0.5 recurring is less than 1. Same as before, we need to turn this into a coefficient of 5.5 multiplied by 10 to the negative 1. That is 0.5 recurring in standard form. We need to multiply that by 10 to the 18. And then tidy up your powers of 10. So do negative 1 add 18. Well, that's going to give you positive 17. So that is your answer. 5.5 recurring multiplied by 10 to the positive 17. Okay, our last example is a bit of a harder one. Let's see how we do this. Let's calculate the following. Leave your answer in standard form. We've got 3 multiplied by 10 to the power of 3 all squared, divided by 4 multiplied by 10 to the negative 5, divided by 1 multiplied by 10 to the negative 2. So lots going on in this calculation. Let's tidy it up as best we can to start with. Let's tidy up the numerator. When I have a power like this outside my bracket, it means I need to apply that power to both of the things inside the bracket. Now that's only true when it's multiplication. So for example, if I had 1 add 2 to the power of 2, that is not equal to 1 squared add 2 squared. And let's show you why that's the case. If I do 1 add 2, that gives me 3 squared. 1 squared is 1 and 2 squared is 4. 3 squared is 9 and 9 is not equal to 5, okay? So applying the power, in this case 2, to both numbers inside the bracket does not work if we're adding the numbers. But let's look at what happens if we're multiplying them. So if instead we had, let's say, 2 multiplied by 3 squared, and we say that this is equal to 2 squared multiplied by 3 squared. Well, let's see if that's true. Do 2 multiplied by 3 inside our bracket. Well, that gives us 6, and we're squaring that. 2 squared is 4, 3 squared is 9. So 6 squared is 36, and 4 multiplied by 9 is 36. So this works, applying the power to both numbers inside the bracket, and it works when we're multiplying. And on our numerator here, we are multiplying these numbers, so I can apply the power to both the 3 and the 10 cubed. So I'm going to write that as 3 to the power of 2 multiplied by 10 to the power of 3 squared. And that's over this calculation here. Let's actually just do this denominator calculation over here to the bottom of the screen. So 4 multiplied by 10 to the negative 5, and we're dividing that by 1 multiplied by 10 to the negative 2. Pop some brackets around both of these. And we'll just do this calculation like we've been doing it for the whole lesson. I'm going to do 4 divided by 1, and I'm going to multiply that by 10 to the negative 5 divided by 10 to the negative 2. 4 divided by 1 is 4, and then I'll tidy up my tens. I need to subtract my indices. I'm doing negative 5 subtract negative 2, which is equivalent to negative 5 add 2, which is equivalent to negative 3. So 10 to the negative 3 is the result of that. Now I know that that's what this denominator works out as. I can write it over here, 4 multiplied by 10 to the negative 3. Let's get rid of this and then we'll go from there. At this stage, I still need to tidy up my numerator, so let's go ahead and do 3 squared to give us 9, and then apply this power to the 3. This is a power upon a power, multiply your indices. That gives you 10 to the power of 6. We're dividing that by 4 multiplied by 10 to the negative 3. Let's split that into the two fractions, so 9 over 4 multiplied by 10 to the power of 6 over 10 to the negative 3. 9 over 4 is going to give us a decimal. How many times does 4 go into 9? Well, it goes in twice to give me 8 with 1/4 left over. Therefore, it must be 2.25. And then I'm going to do 10 to the 6 divided by 10 to the negative 3. Subtract your indices. Remember, I'm subtracting negative 3, equivalent to adding 3. That's equal to 9. So 2.25 multiplied by 10 to the power of 9 is my answer. Pause the video, give this one a go, and then we'll look at the solution. Let's start by tidying up our numerator. So I'll apply this power of 3 to the 2. That's going to be 2 cubed. And I'll apply it to the 10 to the negative 4 to give me this. On the denominator, I need to figure out what this is. So I'm going to do 8 divided by 4 to give me 2. and I'm going to do 10 to the power of negative 7 divided by 10 to the power of negative 9. Let me just write that out so we can see it more clearly. So like this. When I'm dividing these powers of 10, I need to subtract my indices. I'm doing negative 7, subtract negative 9. Really important that I keep track of that. That's negative 7, add 9, which is equal to 2. So this bracket works out as 10 to the power of 2, which means this denominator is 2 times 10 to the power of 2. So I'll rewrite that like this. Then I'll get rid of this writing. So I know I've got this fraction. I've tidied up my denominator to this, and I've started to tidy up my numerator to this. Let's finish tidying up the numerator. 2 cubed is 8, and then 10 to the negative 4, all to the power of 3. Multiply your indices together in this case to give you 10 to the power of negative 12. And we're putting that over, we're dividing it by 2 multiplied by 10 to the power of positive 2. That's 8 over 2 multiplied by 10 to the negative 12 over 10 to the power of 2. 8 over 2 is 4, and then negative 12 subtract 2 goes to negative 14. So that should have been what you got. If you're using our lesson booklets, you can now complete exercise 1 to 4, where we practice a lot of what we just covered in the lesson and some extra problem solving questions. Thank you for watching the video.